when you want.
Okay. Well, welcome everyone. Today, our group is going to talk about branching patterns, what they are, their impact, what they offer, and a comparison between them. So, first of all, let's start with some base patterns. What happens when we have a project and several people have to work on the same files? Source branching answers this question by offering a system that allows us working separately on the same code and then joining it back. With a system of branches, we can have a separate branch where we work. And a branch is a series of commits, and the head or tip is the last commit. When two commits are made in parallel, we have the branch splits. With those branches, we can merge them into another to resolve parallel changes without major consequences. If no commits were made during the last merge, any change made will be applied in other branches. However, when we have different states on branches, we have to bring the code together, solve the conflicts, and merge our branch into the one we want. We have to solve those problems manually, and it requires human intervention. Well, now let's see mainline. Mainline is one of the most important concepts on these presentations, as is the base for many other patterns we will see. When there were no branches at all, it was a nightmare to put all the teamwork together. So it's a very good option, almost using most of the projects, I think, team projects. And the mainline is a special code line that we consider the current state of Teams code, and every new feature implemented starts from it. But we cannot talk about mainline without talking what is a healthy branch. Well, we can define the health of a branch in if there is a successful build and running software with few, if any, bugs. It is very important to keep the health of every branch because when you, especially of the mainline branch, because if you want to start implementing code from the mainline, you have trust on your team that the branch is healthy, and then you only have to worry on the code you have implemented. Most of the times there can be some incompatible things or that. And you increase the production as well. You start implementing it directly and you can debug it easily. For keeping the health of a branch, it's compulsory having a well-made self-testing code or suite that can perform tests in a quick way, so you don't have to wait a lot of time by testing everything in your code. Well, now we have seen those base patterns. Let's see some more difficult one. Let's go to the integration patterns. And one of the most used patterns is the mainline integration. With mainline integration, we have a clear definition of the current state of team software development. The procedure is as simple as developing code on your own, and then, when you are finished in your personal branch, pull the code from the mainline and solve the conflicts. There can search many problems during mainline integration, which, like for example, doing two people start merging at the same time, so one have to pull two times or something like that. But my friend Khan is going to talk about it in feature branching.
Can you hear?
Yeah.
Yeah, okay. Actually, I start with the integration frequency. Integration frequency, in my opinion, is the most most important thing for integration something to the mainline. Because if there is no well-set frequency, it will probably cause many problems, and we don't want that to happen. Now, let's explain how it works. I'm gonna start with the low frequency because it's the way we shouldn't use it while we are doing integration. You will see what I mean when we come to ends. You know that everyone has to keep up with the main line while working. It means we have to pull all changes, if any, into our local repository. It is the main subject in our situation. Low frequency is something about doing less pushing into the main line, and it requires doing more pulling into our locals. Actually, I think it will be better if I explain the low frequency and high frequency in the same page, like this one. If you take a look at the picture, you will understand why we are using the frequency word here. And there is one main difference between these, and this difference is pushing frequency. And it's very critical for the mainline's health. If we do something like this here, and I mean, if we keep doing comments on local repository and never do any push into the mainline, and one of our teammates does the same thing, and if there are issues back in our code or our teammates' codes, this merge will be deadly, impossible to deal with. But if we use high frequency, I mean, if we do more passing into the main line, merge will be too much easier to deal with. And we want that to happen. Some say doing that because of integration fear, because of the consequences. But in my opinion, this is what we should do. We have to do. By the way, I like this slogan, and I wanted to add it and share with you. If it hurts, do it more often. I know it doesn't make too much sense alone, but I guess it explains the situation here. Whatever, we only talk about problems. Let me give you some solution here. Like self-testing codes. Of course, all the things I talk about high frequency is still on top. But self-testing codes can help to find bugs and issues. And it is very useful for us, especially when you work with high frequency and self-testing code together. Your team will build everything faster, and this means a quick end. You know what I mean? As of now, we know the high frequency works wonders, but there is a new question about how frequently will we merge? This question belongs to continuous integration, and it has its own answer for that. There's one rule. If you want to make your mainline stay healthy, do not isolate yourself from the mainline for more than a day. Of course, if you are working on the project at the time. If we talk about trunk-based developments, which term some people use instead of continuous integration, this part's not a concern to us, but most companies use them to automatically build feature branches. Then, if I come to the main subject, while you are using continuous integration and self-testing code together, you don't need to worry about bugs, and you don't need to separate the local branch either. Let's talk about the difference between feature branching and continuous integration. If you want to say it is better than the other one, but we can't do that because it depends on the teams being able to create features in less than a day. And of course, if they could that, continuous integration provides higher integration frequency, and this frequency provides the team smaller merges and less work to deal with and reduce any risk. However, if we don't know how long it will take and the size of the feature, things will change this time. Feature branching will take the role now. Let's look at the picture for the main difference. I can't see. Wait. Yes, this one. I couldn't read that. All the code and feature can be assessed for quality as units. This means actually because of all features are complete. And feature code only added to product when feature is complete. This is the main thing for feature branching. Less frequent merges. This because of the waiting for features completed always. And continuous integration, if you take that, supports higher frequency integration than feature length. And because of the high frequency, reduce time to find conflicts because of the high frequency, smaller merges, and encourages refactoring. All of it because of the high frequency. But requires commitment to healthy branches and self-testing codes. This is a little challenging, but we have to do that. Scientific evidence that it contributes to higher software development. Actually, I couldn't find it, but if he says there is one, I guess. Actually, there is one more thing about feature branching that I should mention. I want to mention actually. This is pull requests, called pull requests. Prevents code issues with, like, I'm ready to merge. Then I have to ask, can I merge my code with mainline? Yes, of course, or no, you can't. And not right now. The line is busy or something like that. That can be useful, I agree, but it makes things slower. If you want to say that you should be coordinated with all your teammates. And my friend, take that part.
Okay, so when integrating, some people prefer using pre-integration review, which would be pull request in case of GitHub. Well, that is a mechanism for it. This consists basically on a process that happens before pushing something to the mainline, in which the developer sends the commit to a review, and then other members check it and make some comments about it. This commit is changed, and this process repeats until they decide that the commit is good enough to be placed on mainline. Pre-integration grew in popularity with open source because of the structures of maintainers and contributors, where the formers cannot totally trust that what the latter will try to push. In this way, the maintainers can check the code before accepting it. The principal problem of pre-integration reviews is that it generates integration friction. This term includes all the activities that make integration take time or be an effort to do. As integration friction grows, the developers will tend to lower the frequency of integration, and that will lead to more friction again, and so on. Thus, unless it clearly adds value, any friction should be removed. Then modularity also impacts integration. Often teams have more problems integration precisely because of the lack of modularity. But now that was all for the integration patterns, so we'll now explain some patterns to facilitate the path from mainline to production. The first one would be the release branch. A typical release branch will copy the content from the current mainline in a concrete moment. The developers working on the release focus only on removing any defects that stop the release from being ready for production. Teams that only have one version in production at a time will only need a single release branch as in the first schema. But some products will have many releases present in production use. In this case, the development team keeps release branches open for each release and fixes them as needed, as in the second schema. If the mainline is kept sufficiently healthy, then any commit to mainline could be released directly and release branches wouldn't be necessary. In that case, releases are usually selected using tags. Then we have the maturity branch. They provide a way of tracking the most up-to-date versions of the source. The idea is that once a version of a code reaches a certain level of readiness, it's copied into the specific branch. The principal benefit of this is that it clearly shows each version of the code that reaches a stage in the release workflow. The branches are usually named after the appropriate stage in the development flow, but maturity branches can be easily substituted by a tagging scheme. And thus, they can add some convenience to the workflow, but many organizations find tagging to work perfectly well. And then we have the long-lived released branch that is basically a mixture of the release branch and the maturity branch. It is kind of a reused release branch that is maintained instead of creating a new one for each release. But this approach is only suitable for products with a single release in production at a time. Okay, so now Luis will explain the rest to you.
Okay, here, this is the environment branch. It's a very useful pattern. We use it when we try to integrate the application in different environments. For example, we try to do for different operating systems, but we have to be really careful because at the end, this may be an anti-pattern in the way that maybe when you, for example, find a book on some of the branches of a given environment, you can think that this is a book of the application when in reality it's just related with the configuration. So most of companies, what they do is just build a executable for the program that will be used in every different branch, and then use configurations files to ensure that everything works the same way in every environment. Then the hotfix branch, also very used in every kind of development. It's just when you, for example, create a new release. We can see here release version 2.2, and you find a bug that is really important to fix as soon as possible. You create a hotfix branch, and the thing is that you have to give the highest priority to that branch and make sure the bug is solved as soon as possible, and then just cherry pick this this solution to the mainline of the application. And then release train. This is a bit more complicated. It's when you want to create when you want to create a release for a given interval of time. For example, here we have for every month we have a train. When the train departs, you stop making implementation in that branch and you change to a new one. So when you design the features you want to implement in your application, you can decide in which of the trains you want to implement them. And then once it frees, you can just make fixes to the release. And there's a little variation here where there are more than one trains loading at the same time. So, for example, if we want to develop different features from different branches at the same time, for example, by different groups, we can do it. And if we can skip one feature to be developed in the March, for example, in this example, to the April, we can also do it. And the last one, the release reading mainline. This is like the most simple one, and it may look with a bit like a contradiction with what we have seen. It's like all those patterns. There's like a very more simple option. Just use the mainline as the release branch. But in fact, this is very useful if you have, for example, continuous integration and continuous delivery, and all the team is very collaborative. So you have to keep in mind that the mainline have to be as healthy as possible. So the release is always at the healthiest state as possible. And just to to end, we have the other patterns that can be combined with all the patterns we have already seen. There are mainly three. The experimental branch, very simple, used when you want to implement a functionality or a solution to a problem, but you are not sure how to do it. So you do different approaches and then just take the one you like the most. Collaboration branches, when in some part of the development, the code of the developers are not visible for the rest, so you just want to share with the team part and just create a branch that may be pull and push by several teams and then delete it. And the last one, the team integration branch, it's used as a mainline of subgroups of the team. It's useful, for example, when the different subgroups have a different integration frequency. So you can create this branch as a mainline and take the frequency the subgroup feel more comfortable with. And I think this is all. Now we can do the question part.
Okay, thank you very much. I'm going to stop the recording.